Okay, guys, so let's do the first half of section 6.4 together. We'll do examples 1 through 3, maybe, and then we'll do example 4 through 8 next time. Okay? So, section 6.4 is about selecting and drawing conclusions from samples. So, how do I sample first to make sure that when I draw conclusions that they're valid? Okay, that my conclusions are valid based on a valid sample and an unbiased sample. Okay, so first of all, I drew a little picture for you. This is not in your textbook. Actually, a lot of this is not in your textbook because your textbook doesn't quite outline it this way. So I put some things together for you. So first of all, it says a population is a group of individuals or objects that you want information about. Could be people, animals, things you manufactured, literally individuals or objects. Okay, that's your population. And usually the problem with the population is that there's too many people or objects or things in my population for me to get access to all of them to inspect them for some specific measure. So let's say my population is the US voting age adult, and I want to know who they're likely to vote for in the upcoming presidential election. Well, I can't get to all of the US adults that are voting age, and so I can't, my population is too big. Okay, so what we end up doing is taking a little sample of that population, and when you ask the sample, who are you planning on voting for in the next election? Okay, so population is the larger group, but usually when it's too difficult, time-consuming, expensive, etc., for me to gather information from or about every individual in the population, we take a sample. Okay, and I think the picture illustrates that pretty well. And then a sample usually consists of a lot less individuals, but we want to make sure that the sample is representative of the population. So the way in which I pick this little group here that we call the sample, okay, that must be done in a way that makes sure that the people in this group are representative of the whole population, right? And that's not easy to do. That requires some thinking, okay? And so it says in order to draw accurate conclusions about a population from a sample, or to obtain a representative sample, in other words, to take a good sample. We call a good sample unbiased or representative, okay? You must use an unbiased sampling technique. So the way that I go about picking these people for my sample must be unbiased, all right? So unbiased just means I don't favor any particular part of the population when I pick my sample, okay? So I don't get a sample that includes more of one type of person than another, okay? Basically is what we're talking about. So a sample that is selected using an unbiased technique will contain individuals that are representative of the entire population. And then when I get information from the individuals in that sample, I can make accurate conclusions about the population. All right? A sample that contains individuals that overrepresent or underrepresent parts of the population is a biased sample. A very good example of this is the previous presidential election, when it was Donald Trump and Hillary Clinton running for president. Most of the polls showed that Hillary Clinton was going to win the presidential election pretty easily, but that didn't happen because there was an underrepresentation of parts of the population in the sampling that was done. Okay, and that part of the population was people who wanted to vote for Trump. So some demographic of the US population was underrepresented in the sampling that was done. And they got biased samples, which led them to make incorrect conclusions that Hillary Clinton was easily going to defeat Donald Trump in the presidential election. So, we understand population and sample, hopefully. And then we say that the samples must be unbiased. That's what we really want. Okay, unbiased samples. So let's look at some ways people sample, and then make sure you understand which ones are bad and good, and what would make a sample bad and what would make a sample good. Okay? So here are some examples of biased and unbiased sampling techniques. So I grouped the biased ones here, and they are self-selected, which your textbook uses self-selected. In AP statistics, we call it voluntary response sample. In other words, self-selected is a good word, though. I pick myself to be in the sample, or I volunteer my response. Okay, that's another way of thinking about it. So in a self-selected sample, members of the population volunteer themselves to be part of the sample. People usually volunteer to be part of a sample because they feel strongly about a topic or issue, and this leads to systematic overestimates or underestimates. You can actually, if one is an overestimate, then you're underestimating something. Okay, so you can view that glass half full or glass half empty. And self-selected samples, when you give people the opportunity to choose themselves for a sample, they are not representative of the population as a whole. Okay? So an example, when we were running up to the election of Donald Trump last time, which was 3 years ago, I did an experiment in my class, and I said, hey guys, who wants to vote for Donald Trump? Okay? Or who thinks Trump is a good candidate, or who thinks Trump's a bad candidate, any of those type of questions. And certain students raise their hands and very adamantly go, yeah, I like Trump, or vice versa, yeah, we hate Trump. And they've selected themselves to be in my quote-unquote sample at that point. And if you were to then say, oh, what does Mr. Dietlif's Algebra 2 class think about who should win the election, you would just go by the few people who raised their hands, who picked themselves to be in the sample. But that's actually not representative of the whole class. Maybe the students who didn't say anything were afraid to say something, okay? Or they didn't know enough. So that's not representative of the whole population. The other one is a convenience sample. And a convenience sample consists of members who are part of the sample were selected because they're easy to reach. Okay, people who are easy to reach, maybe a captive audience. Like a convenience sample would be me just talking to my algebra students. Hey, you're convenient, you're in my class already, I can just get you, you're easy to talk to, blah, blah, blah. But that's not really a good sampling technique. Okay. Usually, people in a convenience sample are grouped together because they have something in common. So if I'm use my Algebra 2 class as a sample, they all have Algebra 2 in common, but they have many other things in common too. Maybe the same grade level, whatever. Okay, maybe the same other classes they're not enrolled in. So many things they have in common. That doesn't really represent the whole population of students at YES. Algebra 2 students don't necessarily represent the whole population at YES of students. Actually, not too bad, because it contains, usually Algebra 2 class contains a lot of different students from different grade levels, but mainly certain grades, and so it's still not really representative of the population. Okay? So that's a convenience sample. Convenience sample bad. Very bad, very bad. Okay? And I'll let you think about some ways in which you can have convenience samples. But those are biased sampling techniques. Let's focus on unbiased sampling techniques. We want to use unbiased samples, not biased samples. Okay? And so the first one is a systematic sample. All right? And that means you make a rule or a formula to let you decide who to pick to be in your sample. So here's the great example. I don't really have to read the rest of this. Is you choose the first individual randomly. So let's say things are coming off a manufacturing line. I randomly decide which thing to pick first coming off the manufacturing line. Okay, and then I say select every fifth thing. And so that makes it systematic. When you have this rule, every fifth, or this would be like 5n, that's your formula, right? So every fifth individual or item coming off a production line, then it would be a systematic sample as long as you have the first individual chosen randomly. then it's not a bad sampling technique. Okay, it should be unbiased because there's no necessary you're not necessarily favoring one part of the population over another. All right, and then the best technique to use is just a truly random sample. So in a random sample, each member of a population has an equal chance of being selected. Well, that seems like a good idea. To avoid bias, everybody just has the same chance to be in the sample. And I randomly pick some people and they all had the same chance to be in the sample. And I don't favor some people because they have some kind of a quality that others don't. Okay? That's a good way to do it. And then the simplest type of random sample is a simple random sample. Ooh, that makes simplest type, simple random sample. And we'll do this in example 4 and 5. We'll show you how to take a simple random sample. But that's the ideal. You would like to take a simple random sample if you can. We can't always do that. So we don't really learn about other random sampling techniques in this class, but there are other ones. Simple random sample is nice and ideal and easy, okay? But that's not always possible to do because sometimes that's difficult. Any case, we won't worry about that too much. So you can think about this very deeply, please. Think about this. How would I go about taking a sample like this, like this, like this, or like this? Okay, this we'll do in example 4, so don't worry too much if you can't figure out how to do random sampling. That is quite tricky, actually. Alright, so then example 1 says this, and I think what you should do is probably pause the video and try and answer example 1, 2, and 3 all by yourself. You don't really need me to be doing this for you initially. Try and do it yourself because I think students usually think they know this very well. Okay? And do example 1, 2, and 3, whether you've printed out the note sheet or you're just doing it on paper or something, and then you can come back and see what I think and the textbook thinks the answers are. Alright? Okay, so example 1, a sports writer wants to survey college baseball coaches. So college baseball coaches, this would be my population, about whether they think wooden bats should be mandatory throughout college baseball. Identify the type of sample described. So this is my population. What's the sample that was chosen? That's the question. All right. So the sports writer contacts only the coaches that he has cell numbers for in order to get quick responses. All right. So only the coaches he has cell numbers for. This would be my sample right there. But if I already have their numbers and I want to get quick responses, that seems like they were just easy to reach. So these are just easy to reach individuals, right? Which we would call a convenience sample. All right. But this is flawed for many reasons. So this is definitely biased. And you need to be able to propose why this might be biased. So if I have phone numbers for coaches, maybe they are my friends or we work together frequently or something. And so these coaches, you should be able to come up with this. These coaches may feel the same way as the sports writer, right? As the sports writer. Because they're my friends. Maybe. That's one possibility, okay? And so then I'm just going to get a bunch of people that feel the same way, but that's not necessarily representative of all college baseball coaches. All right, so this is definitely convenience. Sports writer mails out surveys to all coaches and uses only the surveys that are returned. Okay, so coaches who return their surveys. That would be the sample here. Okay, and so when I choose to send in my survey, I am selecting myself for the sample. Right, so this could be self-selected or voluntary response. Okay, I don't have to respond. I can just volunteer my opinion by sending in my survey, or I select myself to be in your sample. Okay, and same thing here. Maybe people who don't care about what type of bat you use won't send in anything. So you can say maybe coaches that are passionate about using wooden bats, okay, all send in surveys. Then you see that would be a biased sample because it's just the people who are passionate about wooden bats, and the people who don't really care don't give you their opinion, right? But that doesn't represent everybody. So that's biased sample. This is also biased. Alright? Biased. Alright, so example 2. Manufacturer wants to sample the parts from a production line for defects. Sample the parts from a production line. I think I used that example earlier. Identify the type of sample described. So the manufacturer has every 5th item on the production line tested for defects. So this is literally the example we had, 5N. Okay? So this would be a systematic sample. Except that they should pick the first item randomly. Alright. And then you use a computer to randomly identify. You use a computer to randomly identify 50 times during production to select an item for testing. Okay, so randomly identify. Well, that should be a random sample. It's the only sampling type that has the word random in it. Okay, so this would be a random sample. And both of these are unbiased, we said. Remember that. They are unbiased. These are good sampling techniques. Alright? Alright, so example 3, tell whether it's biased or unbiased, explain the reasoning. Okay. So it says the manager of a concert hall wants to know how often people in the community attend concerts. The manager asks 50 people standing in line for a rock concert how many concerts per year they attend. Okay. So think about this. There's 50 people standing in line at a rock concert. I walk up to the line and I just go down the line and ask them how many concerts do you attend per year. Alright? So I think if you identify the sampling technique first, then you can easily see if it's biased or unbiased. So there's 50 people in the line. That's easy to get to. Okay? They're not going anywhere. They're not going to go out of the line because I'm bothering them, asking them questions. So they're kind of trapped there having to listen to me. So this is definitely what we would call a convenience sample. But what would this lead to? I'm going to people in line to watch a concert and ask them how many concerts a year they attend. Right? So you should be able to say, okay, what would this be? This would be, this would likely overestimate the proportion, okay, proportion or number of people who attend concerts, okay, who attend concerts, who attend concerts often. Let's put it that way. Concerts often. Okay, because this question was how often people, all right? So this will probably overestimate people who attend concerts often, so this would be biased sample, all right? So you knew that. Convenience sample is biased, done, but what is this going to lead to? I'm overestimating people that attend concerts often. All right, next one. Magazine asks readers to send in their responses to several questions regarding healthy eating. Oh, okay. Send in their responses. All right, that sounds a lot like voluntary response or self selected sample right there. Okay, because they send in their responses. They choose to send in their responses. So I select myself, or I choose to voluntarily respond and give you my response. Okay, and who am I going to overestimate here? Several questions regarding healthy eating. So probably healthy people will respond. Okay, because they're passionate about their diet. About diet and health, something like that. Okay? And so this would be an overestimate of what? Of healthy people. Okay? Of healthy readers. Alright? Overestimate of healthy readers. Something like that. Readers of the magazine. Alright? And if you've said this, you know it's biased. Alright, so again, remember, biased samples do not represent the whole population. This one had an overestimate of one group, this had an overestimate of another group, and therefore you're underestimating part of the population at the same time. So that's it for the first part of this lesson, guys. I will post homework there that's got this split in half, so you can just do half the homework. All right.